Okay, so this is a really cute little device that I use to visualize the way that complex phenomena emerge from seemingly simple materials. I call them PM plots for the following reason. Sometimes in physical systems, it's useful to distinguish between the constitution of a system, which I'm going to say is M, and the construction or the organization of the system, which I'm going to call P. These are two things that we can vary on purpose. And just some quick terminology, the reason I've chosen P and M. M, in this case, stands for materials. And P stands for patterns. Now, there's a really interesting nuance in these words, and the reason I've chosen them as such is because I have an obsession with the English language and mostly the Latin and Greek portions of that. Patterns comes from the word pater. Materials comes from the word mater. And if you're quick with words, you've probably already figured out this means father, and this means mother. And in general, most of the phenomena that we're going to look at require a father and a mother. But really, if you really think about the significance of this dichotomy, a lot can be gleaned from this way of organizing our plot. Matter, the word matter, which we deal with extensively in physics, also comes from the word mater, and matrix, and several other verbal tricks, I guess. But we're not so concerned with that right now. We are really just trying to figure out what exactly a PM plot is useful for. So let me start you off with the simplest PM plot that I can think of. Let's say that I have some blocks, and these blocks don't interact with each other at all. I literally just, I put them next to each other. As I add blocks to this system, nothing changes about the organization of that system. Nothing new happens. There's just more blocks. So what I would say about this is that it's a simple system. Nothing is emerging. We'll call this, I'll just call it simple. This is not necessarily to, come up with a definition of what is simple and what is not, but it's a useful little tool to say, okay, this is characterizing what a PM plot is. Let's have a different situation. Let's say I have people, and I like baseball. Let's say they're all baseball players. If I have one baseball player, they can't do much anything. There's really nothing they can do. They can throw the ball up and catch it themselves. That's it. Now, let's say I add one person. Now, our two people can play a game of catch. That's an emergent quality of the system. Let's say I have three people, not much happens, we can play a bigger game of catch, there's really not much going on. I don't know, maybe you increase the complexity a little bit. Let's say I have 9 people. 9 is the number that you need to field the entire, cover the entire field. Suddenly I can have practice. Maybe I can have a scrimmage with myself, I don't know. If you've ever watched The Sandlot, kids figure things out, you can play a baseball game with 9 people. But let's say I all of a sudden have, more teammates, maybe my practices get better. What if I have 2 teams? Well, now I can play a game. I have a baseball game. Let's say I have 10 teams. I can have a league. On and on. This system has the property of increasing in complexity as you go on. More and more hierarchical levels of structure emerge as I add more and more baseball players to this system. So I'll call this baseball players. And I'll call this, we'll call it structural complexity, because I'm going to use that later. Now, this idea of a hierarchy, which is something I mentioned in passing, that's going to come into play a lot. Oh man, I always forget how to spell this. I believe that's correct. Hierarchies are intrinsically bound to the study of complexity just because they occur so often. They may not be a canonical necessity for a complex system, but they are certainly an important aspect of complex systems. And if you want to know more about it, there's a paper that you should read. It's called The Architecture of Complexity by, I believe, Herbert Simon. Architecture of Complexity. And it's just a beautiful paper. Herbert Simon was not a physicist, alas, so you may, if you prefer to avoid the physics in complex systems, that may be a better option, but Google that, read it, it's a great read. It's a little long, but it is very insightful and helps you visualize things in the field of complex systems. Now, let's talk about one more case that a PM plot could be useful for, and I'm going to say that I have a kitchen, okay? And props to anybody who can already discern which cliche I'm going to be using in this plot. But let's say I have a kitchen, and I have one guy. This one guy, or gal, can make a dish per hour, maybe. It's a good dish, I don't know. So one person can cook at a certain rate, and they can do, a certain quality of job on it. Let's just assume that all cooks in this world are the same. That's my physicist coming out. But all cooks have exactly the same abilities. Cool, we can accept this. What happens when I add another cook? Okay. Well, now you can divide up tasks. Maybe the cook in the first case had to, stop what he was doing at some point to do something else. This breaks up the flow of progress, and it makes them take longer. So we add another cook, and we can get a pretty significant increase in what they can do. Notice that, and I just want to point this out, I'm using discrete steps. That means as I add one person, my productivity jumps a certain amount. It doesn't go up continuously, because I have, really discrete difference between one person and two people. That's an important distinction to make. Same with the baseball players. I know I messed up there, but whatever. What happens when I add three cooks? Maybe, just maybe, when I add a third cook, I don't get quite as much of a boost in productivity as I did when I got two cooks. Maybe all of the jobs are already being done. And we kind of see, as time goes on, it doesn't pay off as much to have another cook. And then something happens. Maybe the cooks have a limited amount of space. Maybe they have a limited amount of tools. Maybe they just start getting in each other's way. At some point, if I add another cook, it's going to get harder to do my job. And I'm going to be able to do it, and it's going to take longer. So at some point, as I keep adding cooks, my structural complexity, the organization of this kitchen is going to go down dramatically, to the point where maybe every single cook is making one cut, or putting in one grain of salt into a pot of boiling water. At some point, complexity is just going to go dramatically downhill, and I'm just going to have a room full of people standing shoulder to shoulder, not doing anything because they can't. So at some point, maybe this drops off to zero. So this, I'm going to call these cooks, and I'm going to call this, again, structural complexity. And this is my too many cooks in the kitchen model. Yeah, you got it. So, I'm going to take my time writing this out because I like it. So, we see here that these axes are actually kind of useful for visualizing situations. It's really simple, it's kind of cute, but it gives us qualitative information. I can be reasonably certain in this system that if I have a set of rules that explains what's happening here, I can be pretty certain that those rules are going to apply over here if the qualitative behavior doesn't change. In this system, I can see that, there are increasing levels of organization as I add more and more things to the system. Here, I see that there is an optimum number of cooks that I should have in a kitchen, and that it would be bad if I'm going for, maybe a fast food restaurant and I want to get food out quickly. It would be bad to have this many cooks. These are all things that are well known in other fields. This concept of a simple system is crucial in physics. This idea of optimization in economics is part of the entire set of rules that we use in business, any kind of consumer activity where there's what's called a marginal increase in efficiency. So PM plots can be very useful in terms of visualizing qualitative aspects. Once again, if you have any comments, criticism, constructive or destructive, doesn't matter to me. Do something. Otherwise, I'm just going to keep talking to the camera.